Hello everyone, this is Balu. Welcome to my channel SealCafe. In this video, I am going to discuss about the applications of different shaped sections in the construction industry. Before going into this video, I already discussed about the structural behavior of different shaped sections and also comparison between I section and hollow sections in my previous videos. If you have not yet watched that video, please go through that videos and those video links is in the description. Now coming into this video, here you can see this is the I section. This I section is basically used to resist flexure, compression and shear, but it is not having much torsional resistant capacity. It will give you the optimum design. We also know that it is a universal beam. It is having good compatibility of connections also, but it cannot be loaded with respect to its minor axis, that is YY axis. It is not having much strength with respect to this minor axis. Here you can see these are the I girders which are placed on the pier cap in between the two piers. This is basically the metro construction is going on here. And also these I girders are used to resist the high loads coming onto the structure. On this I girder, they are going to catch the deck slab so that they can lay the tracks on it. And not only the I girder, different shapes like U girder, box girder also used in the metro construction. And this picture is related to the erection of the I girder in the sites. And coming to the other applications, this is a plate girder. It is of I shape only. It is a built up section. Plate girders are made of plates only. And you can see these are the transverse stiffeners and these are the shear studs. You call it as shear connectors. If you are going to cast a slab on this plate girder, so that it acts as a connection between the concrete and steel. That is nothing but the shear connector. These plate girders are basically preferred when it is having a large span and heavier loads are coming onto the structure. Used in the bridges and also launching girders. And here you can see this is a picture related to the composite steel girder. This composite steel girder is basically preferred when it is having the higher spans like greater than 50 meters. In the metro construction, when it is having the higher spans like 50 meters and more than 50 meters, they are going to prefer this steel girder, and on this steel girder they are going to cast a deck slab. We can call it as composite steel girder. This is regarding the applications of I section. Channel section. It is used in the UDL applications with small bending capacity, and also it is used as a secondary structural member because it is not having much flexural strength. Next, it is an ideal substitute for I section when flexure is not critical, because I already explained in my previous video, if you cut the flange part from the I section, you are going to get the channel section. So whenever the flexure is not critical element, you are going to prefer this channel section so that you can save the material. Next, it is having a good compatibility for connecting to other steel members also, and it is not suitable for heavy load because it is not having much strength. It is used as a transverse joist in the supporting floor and also purlins for roof trusses. Here you can see this is the purlin in the roof truss, and studs in wall framing, supporting members for ceiling assemblies. This is a ceiling assemblies. You can see this is a supporting member in which channel section is preferred. Next, coming to the angle section, it is used in the point load applications to resist shear, tension and compression. And it is used as a connection member and also primary component of built-up member. I already discussed about many connections like seated angle connection, web angle connection. In those connections also, this angle is used. If you have not yet watched those videos also, please go to this video, and also I am giving those links in the description so that you can understand better like regarding this angle section. It is used as a bracing in the truss members. This is a bracing in the truss member, and also this is a lacing in the compression member, and also it is used as a cords, battens in the built-up members. And coming to the other applications, diaphragm member in the bridge girder system. See, this is a diaphragm member in the bridge girder system. This is a bridge girder, and also it is used as a web stiffening element in the plate girder. See, this is the angle section which is connecting the both plate girders, which is used as a web stiffening element. Coming to the T section, it is used for all load applications similar to the I-shape section, and it offers significant flexural capacity on flange side. That is, here you can see only one side it is flange is present. So it offers significant flexural capacity on the flange side compared to the non-flange side. And coming to the applications, it is used as a connections between I or other sections, and also used as a secondary beam members, that is lintels. It is also used as a chord members and primary member of built up members. And it is also used as a end diaphragm members in bridge girder systems, and all other applications are there for these T-shaped sections. Coming to the hollow sections, it is having high torsional resistance. This point I already explained in my previous video regarding the comparison between I section and hollow section. If you have not yet watched that video also, you can prefer that video so that you can get the knowledge how this hollow section is going to resist the torsional. And also it is having high structural capacity in both direction because it is symmetry in the both direction. And also it can be used as a jacket for concrete column to increase axial load capacity. And it is not commonly used as a flexural members due to more steel usage compared to the I sections. And also bolting is very difficult to install in case of these hollow sections. This is a gusset connection. This is one of the hollow section you can see clearly. Next, coming to the other applications, these are the trestles which are used to support the permanent structures, and later after casting of these permanent structures, these trestles are going to be removed. These trestles are going to resist the compression which is coming onto the structure. I already discussed regarding the why we are going to use these hollow sections in case of the compression, because it is symmetrical in the both directions. Section has to be strong with respect to the both axes, because when we are going to design for compression, we are going to consider the minimum radius of gyration. I hope you all remember that one. R minimum we are going to consider, so that the section which we are going to consider, it has to be strong with respect to the both the axes, so that it can resist the more compression load. This is regarding the applications of different shaped sections in the construction industry. And also share with your friends. And also thank you for watching.